Jai Hind to all. Today we start a new chapter, three-dimensional geometry. This chapter is a continuation of our first year chapter 3D geometry also, where we discuss how to express a point in a three-dimensional space, then distance between 2 points, section formula, and centroid of a triangle in three-dimensional space. In this section, we discuss three parts. Our first is direction ratios and direction cosines. Second is straight line in space, and the third is plane in space. This chapter contains 1 mark question, 2 mark question, 3 mark and 5 mark also. So it's a very important chapter. Also it's a very interesting chapter. So try to practice every problems in NCERT. Also do some extra questions in using any other test. Okay. Now we start the class. Now we start our next chapter is three-dimensional geometry, 3D geometry. Actually this chapter is a continuation of your first year topic, three-dimensional geometry, where we already discussed what is a distance formula, section formula and centroid in a three-dimensional space. Actually in second year, this three-dimensional geometry is connected with the vector concept. For each section, we develop 2 types of formula. That is, first is vector form and second is Cartesian form. Cartesian form means without ijk times we create form equations. Our first section is, there is 3 sections. Our first section is direction ratios and direction cosines. Second is straight line in space and third is plane. CBC deleted a small portion from this chapter, that is angle between 2 line, angle between 2 plane and an angle between a line and plane. This is a simple portion and a small portion. It's already deleted. First of all, we discuss about direction ratios and direction cosine. What is direction ratio and direction cosine? It's actually also a part of a vector. Okay, this portion is also part of the previous chapter, vectors. First of all, we define the vector concept of direction ratios and direction cosine, then convert it to in 3D line. What is direction ratio and direction cosine? In our three-dimensional space, I select a vector. Suppose vector OP. The coordinate of P is ABC. Then you know the position vector of P. Position vector of P is a the x-axis there where there lies I, J and K. Position vector of P unit vector multiple summaയിട്ട് എക്സ്പ്രസ് ചെയ്യുമ്പോൾ vector of P is we get answer AI plus BJ plus CK. That is, suppose you take any other point. Suppose you take P as any point. Suppose you take P. The coordinate of P is 2, 4, 6. Therefore, the midpoint value is 1, 2 and 3. Again, also the midpoint of this point to this point is half of the value, that is 1 by 2, 2 and 3 by 2. The ratio of each point will be, we get answer. Suppose 1 is to 2 is to 3, imply multiply by 2, we get answer 2 is to 4 is to 6. Also 1 by 2 is to 2 is to 3 by 2 is again we get answer multiply by 4, we get answer 2 by 6, sorry here 1, that is 2 is to 4 is to, again we get answer 6. That means വോയ്ക്കും പി എന്ന് പറയുന്ന പോയിന്റും ഇടയ്ക്ക് ഏതൊരു പോയിന്റ്സ് എടുത്താലും ആ പോയിന്റുകളുടെ റേഷ്യോ ആൻഡ് ലാസ്റ്റ് വി ഗെറ്റ് ആൻസർ 2, 4, 6. That means here this 2, 4, 6 is actually the direction ratio of this line OP, vector OP. Okay, that means here PABC is any point in the vector OP, then ABC are called direction ratio of vector OP, because ഒക്കും പി ക്യൂടെക്കുള്ള ഏതൊരു പോയിന്റ് എടുത്താലും ആ പോയിന്റുകളുടെ റേഷ്യോ ആൻഡ് ലാസ്റ്റ് വി ഗെറ്റ് ആൻസർ എ ബി സി. സോ ദ ഡയറക്ഷൻ റേഷ്യോ ഓഫ് ഒ പി ഈസ് എ ബി സി. The position of vector OP equal to AI plus BJ plus CK. Here the direction ratio of vector OP is direction ratio of vector OP is equal to, we get answer A comma B comma C. Okay. Now we define what is direction cosine. Suppose vector OP, this vector OP makes an angle alpha, beta and gamma with a positive x, y and z axis, x, y and z axis. Here the alpha, beta and gamma are called direction angles or directed angles. The cosine of these angles are called direction cosine. That is cos alpha, cos beta and cos gamma are called direction cosines. Cosine of this angle are called direction cosine. Okay. Now we find that using direction ratio we find direction cosines. Actually vector OP is already known. Vector OP is equal to AI plus BJ plus CK. Okay, vector OP is equal to AI plus BJ plus CK. You take vector OP as vector R. You say any point with the position vector is vector R is equal to vector OP is equal to, we get answer AI plus BJ plus CK. And second is suppose vector A, that is easy. Vector A is equal to vector OP. And vector B is, you know, x-axis unit vector is I. Using angle between two vectors already discussed in the scalar product, that is cos alpha is equal to vector A dot vector B divided by mod A into mod B. Alpha is the angle between vector OP and I. That is vector A corresponding to AI plus BJ plus CK dot vector B correspond to I divided by modulus of this vector is A square plus B square plus E square and unit vector modulus value is 1 is equal to, you know, I dot I is 1 and therefore we get answer A, balance J dot I and K dot I are 0 and therefore we get answer A divided by root of A square plus B square plus E square. And similarly we get cos beta, we get answer B by square root of A square plus B square plus E square. And cos gamma equal to, we get answer C by root of A square plus B square plus E square. This is the relation between direction ratio ABC and direction cosines. It is cos alpha is equal to A by root of A square plus B square plus E square is also denoted by the symbol L. Cos beta is denoted by the symbol M and cos gamma is denoted by the symbol N. These are called direction cosine. Therefore, when direction ratio is given, then using this formula we find direction cosine. AB's are already given, then using this formula we get direction cosine. And our next point is sum of the squares of direction cosines is always equal to 1. That is L square plus M square plus N square. You know the squares value, sum of the squares of this term is equal to A square by this term, B square by this term and C square by A square plus B square plus C square, and therefore common denominator is A square plus B square plus C square, and adding the numerator term we get answer A square plus B square plus C square. Cancelled, we get answer 1. That is sum of the squares of direction cosines is equal to 1. That is cos square alpha plus cos square beta plus cos square gamma is equal to 1. Okay, our next point is suppose two vectors with the direction ratios are, suppose the first vector direction ratio is A1, B1, C1 and second vector direction ratio is A2, B2, C2. That is two vectors are already given whose ijk times the coefficient and the direction ratio. Here vector OP is already given, that is vector OP equal A plus BJ plus CK. Then A, B, C are called direction ratio because ഈ പോയിന്റിലേക്കുള്ള ഏത് പോയിന്റ് എടുത്താലും അതിൻ്റെ എല്ലാ റേഷ്യോ ലാസ്റ്റ് നമുക്ക് ABC കൊണ്ടെത്തിക്കാൻ പറ്റും. That ABC are called direction ratio. So suppose you take any other point, this point, then that point is also direction ratio. നമ്മൾ സ്പെസിഫൈ ചെയ്യുന്ന പോയിന്റ് ഏതാണോ ആ പോയിന്റ് കോർഡിനേറ്റുകളാണ് നമ്മൾ direction ratio of that vector. Here two vectors are already given. These two vectors are parallel. Then the condition for parallelism is a1 divided by a2 is equal to b1 by b2 is equal to c1 divided by c2. If two vectors are already given, if two vectors having direction ratios are already given, first vector direction ratio is a1 b1 c1, second vector direction ratio is a2 b2 c2. Since they are parallel, then the condition is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Next point is two vectors whose direction ratios are given. First vector direction ratio is already given a1 b1 c1, and second vector direction ratio is also given a2 b2 c2. What is the condition for perpendicularity? What is the condition for perpendicularity? That is here a1 a2 plus b1 b2 plus c1 c2 is equal to 0. Condition is a1 a2 plus b1 b2 plus c1 c2 equal to 0. If two vectors having direct ratio a1 b1 c1 and a2 b2 c2, since they are parallel, then the condition is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. And if they are perpendicular, then the condition is a1 a2 plus b1 b2 plus c1 c2 is equal to 0. It's also a very important point. Suppose in a three-dimensional space, we select a vector in space. That vector containing the points, that vector passing through the points are a1 b1 c1, and second point is a2 b2 c2. You know vector ab. Position vector of A is a1i plus b2j plus b1i plus c1k, and position vector of B is a2i plus b2j plus c2k. And therefore, vector AB is defined as vector AB is equal to, you know, for the position vector of B minus position vector of A is equal to, position vector of B means a2i plus b2j plus c2k minus a1i plus b1j plus c1k, that is equal to a2 minus a1 into I plus b2 minus b1 into j plus c2 minus c1 into k. That is the position vector of vector AB. And the direction ratio of AB, and therefore the direction ratio of vector AB is, answer is a2 minus a1 comma b2 minus b1 comma c2 minus c1. Okay, that's are the main points regarding the topic direction ratio and direction cosines on a vector concept. In a line, these points are repeated. But suppose in a three-dimensional space, you take a line. OP is a line O and P. The coordinate of P is ABC. Here, the direction ratio of OP, the line OP, is similar to the last vector concept. Direction ratio of the line OP is equal to same answer ABC. The coordinate of P is called the direction ratio because ഈ ഒക്കും പിക്കും ഇടയ്ക്കുള്ള ഏത് പോയിന്റ്സ് എടുത്തില്ല ഇതിൻ്റെ റേഷ്യോ ലാസ്റ്റ് എ ബി സി കൊണ്ടെത്തിക്കാൻ പറ്റും. സോ ദാറ്റ് പോയിന്റ് പി ഇസ് കോൾഡ്, പി കോർഡിനേറ്റ് എ ബി സി ആർ കോൾഡ് ഡയറക്ഷൻ റേഷ്യോ ഓഫ് ഒ പി. നെക്സ്റ്റ് പോയിന്റ്, if OP makes an angle alpha, beta and gamma with three axes, then cos alpha, cos beta and cos gamma are called direction cosine, Using direction ratio, we find direction cosine using the formula cos alpha is equal to a by square root of a square plus b square plus e square. Cos beta is equal to b by root of a square plus b square plus e square. And cos gamma is also c by square root of a square plus b square plus e square. Also, sum of the squares of direction cosine is also denoted by L, M and N. Also, sum of the square, that is L square plus M square plus N square is also equal to 1. It is represented on a line. That's previous topic is represented on a vector. Here L square plus M square plus N square is equal to 1. Then if two lines having direct ratio A1 B1 C1 A2 and A2 B2 C2, condition for parallel is A1 by A2 equal to B1 by B2 equal to C1 by C2. If two lines having direct ratio A1 B1 C1 and A2 B2 C2, condition for perpendicular is similar to last A1 A2 plus B1 B2 plus C1 C2 is equal to 0. And last, a line passing through two fixed points. If direct ratios are A1 B1 C1 and A2 B2 C2, then the direct ratio of that line is A2 minus A1, similar to this A2 minus A1, B2 minus E1 and C2 minus C1, which are also similar to the vector concept. So first of all, we pass through this portion, then understand the concept using this line also. അപ്പോൾ നമ്മൾ വെക്ടറിൽ ചെയ്ത സെയിം കോൺസെപ്റ്റ് തന്നെയാണ് ഇവിടെ നമ്മൾ ലൈനിൽ പറയുക. വെക്ടറിൽ നമ്മളവിടെ ഐ ജെ ഒക്കെ ചേർത്ത് പറയുന്നു. ഇവിടെ നമ്മൾ ഡയറക്റ്റായിട്ട് പോയിൻറ്റ്സ് തന്നിട്ട് ഈ ഡയറക്ഷൻ റേഷ്യോ ആൻഡ് ഡയറക്ഷൻ ക്വസ്റ്റ്യൻസ് ഡിസ്കസ് ചെയ്യുന്നു. ദറ്റ് ഈസ് എനി പോയിൻ്റ് ഓൺ ദ ലൈൻ, ദ കോർഡിനേറ്റ് ഓഫ് ദാറ്റ് പോയിൻ്റ് ഈസ് കോൾഡ് ഡയറക്ഷൻ റേഷ്യോ. ആ പോയിൻറ്റ്സ് ഉപയോഗിച്ച് ആ ലൈനും ഒറിജിൻ കണക്ട് ചെയ്യുന്ന ലൈൻ സെഗ്മെൻറ്റ്, ആ പോയിൻറ്റും ഒറിജിനും കണക്ട് ചെയ്യുന്ന ലൈൻ 3 ആക്സിസോട്ട് മേക്ക് ചെയ്യുന്ന ആംഗിളുടെ കൊസൈൻ വാല്യൂ, ദാറ്റ്സ് ആർ കോൾഡ് ഡയറക്ഷൻ കൊസൈൻ. ഈ ഡയറക്ഷൻ റേഷ്യോസ് ഉപയോഗിച്ചുകൊണ്ട് ഡയറക്ഷൻ കൊസൈൻ കണ്ടുപിടിക്കാനുള്ള ഫോർമുല കോസ് ആൽഫ എ ബൈ റൂട്ട് ഓഫ് എ സ്ക്വയർ പ്ലസ് ബി സ്ക്വയർ പ്ലസ് സി സ്ക്വയർ, കോസ് ബീറ്റ ബി ബൈ റൂട്ട് ഓഫ് എ സ്ക്വയർ പ്ലസ് ബി സ്ക്വയർ പ്ലസ് സി സ്ക്വയർ ആൻഡ് കോസ് ഗാമ സി ബൈ റൂട്ട് ഓഫ് എ സ്ക്വയർ പ്ലസ് ബി സ്ക്വയർ പ്ലസ് സി സ്ക്വയർ. And sum of the squares of direction cosine is equal to 1. Condition for parallel and condition for perpendicularity also noted. Okay. Now we start some problems based on this topic. First question. If a line makes an angle, it is our NCERT 11.1. If you have any doubt in the question, that is 11.1. First question. 11.1 exercise, first question. If a line makes an angle 90 degree, 135 degree and 45 degree with the x, y, z axis, then what is the direction cosine? A line which makes an angle, suppose a line which makes an angle 90 degree, sorry, figure is not correct. Well, suppose you take an angle 90 degree, 135 degree and 45 degree. Okay, a line which makes an angle 90 degree, 135 degree and 45 degree. So representation is very difficult here. So we have to draw the geometrical representation. If a line which makes an angle 90 degree, 135 degree and 45 degree with the x, y and z axis, what is the direction cosine? Here given direct angles are already given 90, beta is 135 degree and gamma is 45 degree. We find the direction cosine. You know the formula L is equal to cos alpha, it is cos 90, you know the value of cos 90 is 0. Then M is equal to cos beta, that is cos 135 is equal to cos 135. Now using reduction formula we get answer 180 minus 45. 180 minus L is in this quadrant, that is second quadrant, you get answer minus cos 45 is equal to minus 1 by root 2 and N is cos gamma, that is cos 45, you know cos 45 answer is 1 by root 2 and therefore direction cosine L, M, N is equal to answer is 0, minus 1 by root 2 and 1 by root 2. It's a direct problem, it's not a difficult one, it's a very simple question. Okay. Next question is, find the direction cosines of a line which makes, this is 11.1, second question. Find the direction cosines of a line which makes equal angles with the coordinate axis. Find the direction cosines of a line which makes equal angle with the coordinate axis. That is here given, the condition is alpha, beta and gamma are equal. Then using this condition we find the direction cosines. You already know the formula, the relation connecting the cosine angle cos alpha, cos beta and cos gamma, that sum of the squares of direction cosine, that is cos square alpha plus cos square beta plus cos square gamma is equal to 1. Here alpha, beta, gamma are equal and therefore we get the answer cos square alpha plus cos square alpha plus cos square alpha is equal to 1, that is 3 cos square alpha is equal to 1, and therefore cos square alpha equal to 1 by 3, cos alpha equal to, we get answer plus or minus 1 by root 3. Similarly, cos beta is also plus or minus 1 by root 3, and last cos gamma is equal to, we get answer plus or minus 1 by root 3. These are direction cosines. Using the condition, a line which makes equal angles with the coordinate axis, that is a line which makes equal angle with the coordinate axis, therefore alpha, beta and gamma are equal. Using that condition, using the condition cos square alpha plus cos square beta plus cos square gamma equal to 1, ഇവിടെ നമ്മൾ alpha beta gamma alpha value കൊടുക്കുക, we get answer cos alpha cos beta cos gamma plus or minus 1 by root 3. Okay. Now let's go more question. If a line with a direction ratio 2 minus 1 minus 2, given a line with a direction ratio 2 minus 1 minus 2 is already given 2 minus 1 minus 2. Find the direction cosines. You know, for the direction cosine cos alpha, a divided by square root of a square plus b square plus c square. Here ABC is already given, that is 2 divided by square root of 4 plus 1 plus 4 equal to 2 by 3. Similarly, cos beta is equal to using formula b by square root of a square plus b square plus e square is equal to b corresponding value is minus 1 divided by square root of 2 square plus 1 square plus 2 square 4 is equal to minus 1 divided by 3, and last cos gamma is equal to using formula c by root of a square plus b square plus e square is equal to minus 2 divided by square root of 4 plus 1 plus 4 is equal to, we get answer minus 2 divided by 3, and therefore direction cosine L, M, N is equal to, answer is 2 by 3 minus 1 by 3 and minus 2 divided by 3 is the direction cosines if a line passing through a single point. Now, next question. Find the direction cosines of a line passing through two fixed points. Find the direction cosines of a line passing through minus 1, 2, 4, minus 1, 2, 4 and 1, 0, 3, 1, 0, 3, 1, 0, 3. Find the direction cosines of a line passing through minus 1, 2, 4 and 1, 0, 3. You know, a line passing through two fixed points. First of all, we find the direction ratio of that line. Direction ratio, the given line is represented by ABC is equal to, you know, for A2 minus A1, B2 minus B1, C2 minus A1. It is 1 minus or minus 1, 1 plus 1, 2. 0 minus 2 is minus 2. 3 minus 4 is minus 1. And therefore direction cosine L is equal to, or cos alpha is equal to, using formula A by square root of a square plus b square plus e square equal to, we get answer 2 divided by root of 4 plus 1 is equal to 2 by 3. Similarly, m is equal to cos beta equal to minus 2 by 3. N is equal to cos gamma is equal to minus 1 by 3. And therefore direction cosines L, M, N are 2 by 3, minus 2 by 3, minus 1 by 3, which is the required direction cosines. Okay, a line pass through two fixed points. First of all, we find the direction ratio of that line using the formula A2 minus A1, B2 minus B1 and C2 minus. Coordinate differential select here. Then find the direction cosine using the formula cos alpha equal to A by root of A square plus B square plus C square, cos beta equal to B by root of A square plus B square plus C square, and cos gamma equal to C by root of A square plus B square plus C square. Now, I will discuss one more question. It's a 11.2 question, 11.2 exercise, question number 2. Question number 2. Show that the line through the points 1 minus 1 2, show that the line through the points 1 minus 1 2, 1 minus 1 2 and 3 4 minus 2, 3 4 minus 2, 3 4 minus 2 is perpendicular to the line through the point 0 3 2, 0 3 2 and 3 5 6 and 3 5 6. Show that the line through the point 1 minus 1 2 and 3 4 minus 2 which is perpendicular to 0 3 2 and 3 5 6. That means here we have to prove that these two lines, already two lines which are perpendicular, prove here. First line passed through the point is 1 minus 1 2 and 3 4 minus 2. First of all, find the direction ratio of that line. Direction ratio of the line passing through, direction ratio of the line passing through 1 minus 1 2 and 3 4 minus 2. Suppose you take A1, B1, C1 is equal to, you know the difference, 3 minus 1 is 2, 4 minus 1 minus 1 is 4 plus 1, that is 5, and minus 2 is minus 4. 2, 5 minus 4. Second, direction ratio of a line passing through the point 0 3 2 and 3 5 6. Suppose you denote by A2 B2 C2 is equal to, you find the difference, 3 minus 0, A2 minus A1, 5 minus 3 is 2, 6 minus 2 is 4, which is denoted by 3 2 4. Now we find A1 A2 plus B1 B2 plus C1 C2 is equal to, A1 A2 means 2 into 3 6, 5 into 2 plus 10, minus 4 into 4 minus 16 is equal to 0. Therefore given lines are perpendicular. Given lines are perpendicular. That's all. Okay. First of all, we find direction ratio of first line. That line is passed through two fixed point. Using the concept A2 minus A1, B2 minus B1, C2 minus C1, we get a direction ratio of first line. Second, we find direction ratio of second line. Using concept A2 minus A1, B2 minus B1, C2 minus B1, we get a direction ratio of second line. Using the direction ratio, we find their sum to product, that is A1 A2 plus B1 B2 plus C1 C2, we get answer 0, and therefore these two lines are perpendicular. Okay, we will discuss one more question. Our third question, 11 point. Next question is 6th, and test question number is 11.3. Sorry, 11.2. Third question. Show that the line through the points. Show that the line through the points 4, 7, 8, and second point is 2, 3, 4 is parallel to second line points are minus 1, minus 2, 1, minus 1, minus 2, 1, and second point is 1, 2, 5. Here you have to prove that these two lines are parallel. Similar to the last question, first of all we find direction ratio of a line passing through, direction ratio of a line passing through 4, 7, 8 and 2, 3, 4 is denoted by A1, B1, C1 is equal to formula 2 minus 4 is minus 2, 3 minus 7 is minus 4, 4 minus 8 is minus 4. Second, we find direction ratio of a line passing through the point is minus 1, minus 2, 1 and 1, 2, 5, which is denoted by A2, B2, C2 equal to 1 minus 1 minus 1, 1 plus 1, 2 minus 1 minus 2, 2 plus 2, 5 minus 1 is 4. Now we find a1 by a2 is equal to minus 2 divided by 2 is equal to minus 1. b1 by b2 is equal to minus 4 by 4 is again minus 1. And last c1 by c2 is minus 4 by 4 is again minus 1. That is a1 by a2 is equal to b1 by b2 is equal to c1 by c2, and therefore given lines are parallel. Given lines are parallel, which is a condition for parallelism. Okay, it's also a very simple question. Try to understand the concept and to do some extra questions also. Okay. Now discuss one more question based on this topic, that is a line with the direction ratio. Show that the points, our question is, show that the points A 2, 3, 4, B minus 1, minus 2, 1 and C 5, 8, 7 are collinear using direction ratio. Using direction ratio, show that the points 2, 3, 4, minus 1, minus 2, 1 and C 5, 8, 7 are collinear. For proving these 3 points are collinear, using direction ratio, concept easy. For first of all, we find the direction ratio AB. Direction ratio of AB is equal to, suppose you take A1, B1, C1 is equal to, minus 1, minus 2, minus 3, minus 2, minus 3, minus 5, 1 minus 4 is minus 3. Then you find direction ratio of BC. Direction ratio of BC, suppose you take A2, B2, C2. 5 minus 1 minus 1, 6. 8 minus 1 minus 2 is 10. Then 7 minus 1 is 3. Sorry, 6. 7 minus 1 is 6. Okay. Now we find A1 by A2 equal to minus 3 by 6 equal to minus 1 by 2. B1 by B2 equal to minus 5 by 10 is again, we get answer minus 1 by 2. And C1 by C2 is equal to minus 3 by 6 is again, we get answer minus 1 by 2. Therefore, here AB and BC are parallel. AB and BC are parallel. Here AB and BC means B is a common point. Here, AB and BC are two lines, but B is a common point. That means A, B, C lie in a same line. Suppose you take AB and CD are parallel, that means there is no collinear, just parallel. If AB and B AB end point, BC starting point, B is the common point. Therefore, since B is a common point, and therefore AB and BC, and therefore A, B, C are collinear. B common point here we say that A, B, C are collinear. So first of all, we have to prove that for proving collinearity, first of all we prove that A, B and B, C are parallel and B is a common point, and therefore A, B, C lie in a same line. That means A, B, C are collinear. That's all. This is also a very important question. Using direction ratios, now you concept prove direction ratio. Okay. Otherwise, using distance formula, collinearity prove. Using direction ratio, first of all, we find the direction ratio of AB and direction ratio of BC. Then, first of all, we prove that AB and BC are parallel, but B is a common point, and therefore ABC are collinear. That's all. Next video, we will discuss straight line and a problem based on that topic. Okay, bye.